Good day, seniors. In this video lesson, we will summarize all the differentiation rules that we need to get the derivative of algebraic functions. First rule, the constant rule. The derivative of any constant is 0. Power rule, or simply the simple power rule. The derivative of a term that is of the form x to the n is n times x to the n minus 1. The constant multiple rule. If you have a constant multiplied to a function, the derivative of that is simply the constant multiplied by the derivative of the function. The sum and the difference rule. Basically, this is simply the derivative of the sum or difference of two functions is simply the sum or the difference of their derivatives. Now let's have this as an example for these rules. Find the derivative of the function f of x equals 4x to the fifth power minus 2 over x squared plus 4 squared of x minus 5. Now, rewriting the given function in the form that we can simply use the simple power rule. So we can write 4x to the fifth. Now, minus 2x squared can be written as 2x to the negative 2. And then 4 squared of x can be written as 4x raised to 1/2. Then minus 5. So you see you have 4 terms here, and the derivative of these 4 terms is simply the sum of the derivatives of each term. And the derivative of 4x to the fifth would be 20x cubed using the simple power rule. So bringing down negative 2, this becomes plus and 2. So you multiply to that constant. So this becomes 4x to the negative 3. Then bringing down 1/2 and multiplying to the constant 4, we have 2. Then the power will decrease by 1. This will become negative 1/2. Now the derivative of negative 5, which is a constant of course, is 0. So this is the derivative. All you need to do is to write this in without negative exponents. So you have 20x cubed plus, this is 4 over x cubed, and then plus 2 over x to the positive 1/2, which you know is square root of x. So the derivative is applying all the 4 rules. Now, the general power rule or the chain rule. Now, do not confuse this with the simple power rule, wherein the derivative of a term of the form x to the n is n times x to the n minus 1. So in the general power rule, the chain rule is incorporated. You see, what is being raised to the power n is not simply x. It is a function of x. So it's a composite function, f of x raised to a power. So you'll apply the power rule first. Bring down n, and what will happen to the power will decrease by 1. However, you will include and multiply the derivative of the function that is raised to the power, which is f prime of x. Let's have these examples. Find the derivative of the function f of x equal to quantity 2x to the fourth raised to the third power. Now, of course, I know that you can simply raise this to the power 3 and then get the derivative of the result. But we will have this, we'll answer this using the general power rule. So let's do that. Let's do both. So f of x equal to, first, we raise this to 3, we'll get 2 cubed is 8, and then x to the fourth, x to the fourth raised to 3 is x to the 12. So the function now can be easily differentiated using the simple power rule. Bring down 12, multiply it to 8, you get 96. The power will decrease by 1. The derivative is 96x to the 11. Now, using the general power chain rule. So, your function is 2x to the fourth raised to 3. You'll bring down that power 3 first. And then 2x to the fourth, the power will decrease by 1, becomes 2. However, we need to multiply this with the derivative of 2x to the fourth, which is inside, right? So, the derivative would be 8x cubed. Now, simplifying this, you get 3 2x to the fourth is 4x to the 8 and then times 8x cubed. 3 times 4 is 12. 12 times 8 is 96. So this is 96. X to the 8 times x cubed is x to the 11. So you see we got same answer, but this expanding it first, this one using directly the general power chain rule. Okay, let's have another. Find the derivative of the function f of x equal to quantity 2x plus 3 squared. Again, we can expand. So we can expand. Let's do that and then get the derivative. So f of x is expanding this will give us 4x squared plus 12x plus 9. And getting the derivative using the simple power rule for each term. So you get 8x, the derivative of 4x squared, and then the derivative of 12x is 12. Derivative of 9, a constant is 0, so this is the derivative. Now let's use the general power chain rule here. So f prime would be bringing the power 2 down first, and then multiplying it by the quantity 2x plus 3 with the power decreasing by 1, so this becomes 1. And then the derivative of what is inside. What is the derivative of 2x plus 3 is 2. So we'll get 2 times 2 is 4. Multiply it, distribute it to 2x plus 3. We'll end with 8x plus 12. Same. Last example for general power chain. Find the derivative of f of x is equal to square root of x squared minus 5x plus 1. This case, we have no choice but to directly use the general power rule. Now we know that the function can be written as quantity x squared minus 5x plus 1 raised to 1/2. So the power would be 1/2. So the function is being raised to power 1/2. So the derivative would be bringing that power down first, then copying it x squared minus 5x plus 1. The power will decrease by 1. This will become negative 1/2. And then chain, derivative of what's inside, derivative of x squared is 2x. The derivative of negative 5x, negative 5. And derivative of 1 is 0. So that's it. So just rewriting this into our final answer of 2x minus 5 all over 2 multiplied by this. The negative exponent will become positive in the denominator. Therefore, this will become x squared minus 5x plus 1. So the derivative. Now, the product rule. The product rule says that the derivative of the product of two functions is simply the first function multiplied by the derivative of the second plus the second function multiplied by the derivative of the first. Or in terms of so that we can easily remember, let our factors be u and v. Then the derivative of the product of uv is u times the derivative of v plus v times the derivative of u, or simply u dv plus v du. Let's have this example for the product rule. So find the derivative of the function f of x equals x squared plus 3 times x cubed minus 4. I know again that you can multiply this and just use the power rule, the simple power rule, but let's go straight to get to solving this using the product rule. Now obviously what you have here is that the first factor, let this be u, the second factor be v. Okay, so the derivative using the product rule would be f prime of x is equal to u, so copy that, x squared plus 3 times the derivative of v, which is 3x squared, plus copy v, which is x cubed minus 4, multiplied by the derivative of u, which is 2x. So just simplify this, and that's the derivative. This would be 3x to the fourth plus 9x squared plus 2x to the fourth minus 8x. So this would be 7x to the fourth plus 9x squared minus 8x. The derivative and the product rule. Last rule, the quotient rule. So it says the derivative of a quotient of two functions f of x over g of x is simply this, or in symbols that's easier to remember. The derivative of u over b would be this: v squared, square the denominator, v du minus u db. V is your denominator and u is your numerator. Let's have this as our example. Find the derivative of the rational function x minus 2 over 2x cubed plus 1. Obviously, the numerator would be u. The denominator would be v. So just follow the rule and simplify. That's the derivative. So f prime of x would be, I usually start with the denominator because it's easier. It's simply copying the denominator, 2x cubed plus 1, and squaring it. And then v du would be copy the denominator multiplied by the derivative of the numerator, which is 1. The derivative of x minus 2 is 1. Minus copy the numerator, x minus 2, multiplied by the derivative of the denominator, which is the derivative of 2x cubed plus 1, which will give you 6x squared. Now, 2x cubed plus 1 minus 6x squared times x minus 2, the numerator will become minus 6x squared x cubed plus 12x squared. So, the derivative would be 1 plus 12x squared minus 4x cubed all over quantity 2x cubed plus 1 squared using the quotient rule. Now, let's on to my favorite part again. Best way to learn, do it yourself. I have here 4 functions. I want you to get the derivative, use the rules for practice. This one is very easy. The answer is this. The second one, obviously, you will use the quotient rule here. This is the derivative. The third one is a radical, but you know, you can write this in the form f of x raised to n. So use the general power rule chain here. So this is the answer. And obviously, the fourth is a product. So you use the product rule. And the terms are being raised to power. So you have here product rule and then chain rule combined. So this is the answer. Now, practice, because you know that practice makes more practice. Now, if you have any questions, you know where to find me at room 508. And if I'm not there, I'm the basement again. Good day, seniors.